Hey everyone, welcome back. In this video, we're going to talk about Kotlin type classes. Now, type classes are generally a loaded term and they're usually associated with functional programming. In this video, we're not going to discuss too much about the theory of type classes, but we're going to focus on type classes more like a design pattern so that you can organize your code better, make it more easy to read and understand, and also easy to maintain and extend. So the best way to make use of this video is to code with me, obviously, as usual. And this video will assume that you know the basics of Kotlin. And as a bonus, if you have some knowledge of Kotlin context receivers, of which we have another video here on the channel. You'll also find a written form at the blog where the author Ricardo added a bunch of extra examples, more that we could cover in this video. So without further ado, I'm going to get back to my development environment. And as usual on the channel, we're going to start with an empty file. So here's an empty Kotlin file, and I'm going to start discussing some code. Now, for this video, I'm going to imagine that we are creating a fictitious fintech company that will allow users to transact stocks, or other commodities. So let's say I'm going to create an object fintech, which will design my little fintech application. And let's assume that this fintech is based on events. For example, a user creates an account, putting some money first, and then they might want to transact some stocks. Maybe they want to purchase or sell some stocks. So I'm going to define some data classes for this, and I'm going to design the data classes as events. And these events will be processed in different ways, and they may or may not be stored in some sort of persistent storage, in a secure storage, and so on and so forth. In the blog post, you will find that these data classes are represented as data transfer objects. I'm simply going to refer to them as events in this video. So let's assume that the data class to create a user account will be create portfolio. And this will be the user ID, let's say a string, and some val amount to be a double. As a side note, never use double for money. I'm just going to use double as for convenience because double is baked into the language. I'm going to create another data class. I'm going to call this change portfolio. With val user ID as a string, a val stock as a string, and val quantity as an int. And this quantity may be negative. For example, if the quantity is positive, then this change portfolio means that it will be buying some stocks. Negative means it will be selling some stocks, for example. And a variety of other events. So other events here. And you may even have an entire hierarchy of events. This may inherit from some general interface and so on and so forth, but I'm just going to create these two so that you can get a picture of what I want to illustrate in this video. Now, if you want to process these events, you'll process them with some functions. Let's call them process. And I'm going to have an event, which would be a create portfolio. And you'll put the logic to create a portfolio here. So logic specific to creating portfolio here. And another fun, let's call this process. It's often useful to overload this thing. So I'm going to have an overload for event to change portfolio and the logic specific here. So notice that we have special overloads for different types so that we can process them differently. If we want to process another event, then that logic sits in a separate way. So this is generally a good organization, at least to start with. Okay, now let's assume that prior to doing the actual logic, we want to validate whether these objects are valid. So I'm going to create an object called storage. For example, a good validation logic would be whether this user exists, whether the amount is positive, whether the stock exists in the database, whether the quantity is not some wacky number, and so on and so forth. So I'm just going to create a val, let's call this users, as a list of some strings. Let's say user-123 and user-333 or something like that, 444. Okay, so this will be my so-called database. Obviously, you can use a real database if you want to search and so on and so forth, but I'm just going to keep this super simple because I want to focus on the organization of our fintech, quote unquote. So let me create some stocks as list of, and I'm going to have Google, and then Tesla, and then Rock the code, and these will be our stocks database. So while doing the processing, we may want to validate the event first. For example, we want to make sure that this user exists and the amount is not negative. for start. So I'm going to say if not storage users, and then contains event user ID, then I might throw an exception or print something. So this would be an error. And I would signify this error as a print line. So error user, and I'm going to inject event.userid does not exist. And I'm going to return from the function because I don't want to process any sort of logic. Otherwise, if not, and I'm going to use the other check that amount is not negative. So I'm going to say if event.amount is negative, then similarly, I'm going to print or signify some error. And I might want to do some sort of private function here to signify an error, but I'm just going to use print line. So error amount is negative. Amount is negative. I'm going to return. And these are the validation checks. And then the logic itself, which I'm going to also signify via print line because prints are the easiest way. So I'm going to say creating new portfolio for user, and I'm going to have my event.userid. Okay, so this is the happy path, and these are the unhappy paths. So we're doing some validation and then doing the actual logic. And similarly for the other one, so I might check whether the user ID and the stock exist in the database. So this sucker will be very similar. If not, storage stocks contains event ID stock, and I'm going to say event.stock is invalid. And again, some processing. And this would be the happy path. And I'm going to say print line. I'm going to have making a portfolio change for user. And I'm going to have my event user ID. And then buying or selling some stocks and so on and so forth with the stock event.stock. I'm just keeping it at that. So notice that for every event type, we have validation logic, and then we have the actual happy path. And some of that validation logic, notice that it's actually copied. We're going to deal with that shortly. And we have to have new process functions for every single event type. So as many event types as we have as many process functions here. Now, this code is okay-ish, but we can organize it a little bit better so that it's more easy to maintain. For example, we may want to put in the validation logic in one place. So we can organize this in a little different ways. I'm going to call this fintech version 2. And in fintech version 2, I'm going to create an interface. So I'm going to have a sealed interface. I'm going to call this validatable. That designs the objects or the types that are subject to validation logic, whatever that validation logic may be. So sealed interface validatable, and I'm going to have my data classes, and I'm going to copy them so that we have them in a separate scope. So we have data classes for all of these events, so with all other events. And I want to make sure that these things both extend validatable. So validatable. So both of these data types are subject to validation logic. This is what this interface means. Now, another way of organizing this said code with process would be to say a fun process, and instead of having overloads for every event type, I'm going to have a single process function which takes an event of type validatable. And I will organize the validation logic in the same place. So I can say event match or a when clause in Kotlin. I've written quite a bit of Scala recently. So when event, and I would test whether this event is of type create portfolio, change portfolio, and so on and so forth. So is validatable dot create portfolio, and then I would do the validation logic plus the processing logic in one go. For example, I would do the validation logic of the sort if not storage users contains, and this event is known to be a create portfolio in this case because Kotlin has some essential flow typing. So we have event.userid. So at this point, event is known to be of type create portfolio. So I can access its user ID. Then I'm going to return unit, and I'm going to print line and so on and so forth. I'm not just going to break the function, but rather I'm going to return unit. So I'm going to have unit, else if, and I'm going to have the same kind of check for amount. So event.amount is less than 0. I'm going to return unit, else, and this would be the happy path. And I'm going to print line, and I'm going to have creating a portfolio for user ID. All right, so this would be the happy path. And similarly, if we have is validatable dot change portfolio, and the when clause is now exhausted, and I'm going to have very similar checks here. So not storage users contains event user ID. If this little thing, then I'm going to return unit, else if not storage stocks contains event user ID, then also you return unit, also with the print lines if you want, but I'm just going to keep this function compact. And otherwise, I'm going to do the other happy path. So making a portfolio change, this little thing. So this would be the happy path for the change portfolio, and so on and so forth for all the event types. So we have other cases for other event types. So notice that this process function is now more compact, and you have one case for every type. So the fact that it's compact is good. The fact that you can see the entire logic is good. The problem is that if you have another event type, so for example, if you want to have an exchange or exchange of foreign currencies, for example, if you want to add a new data class inside this validatable, there's no way to not modify the process function. You have to enter the code inside and add another case for your data type, which will change the way that this process function works. So you need to change existing code, which is not ideal. Ideally, we would like to separate the act of validation from the data types themselves. So I'm going to organize code a little bit differently in this case. So I'm going to create another object. I'm going to call this fintech version 3 in this case. So the code organization in this fintech version 2 is completely different from the organization of fintech version 1. And likewise, fintech version 3 will take this from scratch. So we're going to use some of the logic here, or some of the ideas in fintech version 2. So I'm going to define an interface validatable, but I'm not going to define the data classes themselves here, but rather I'm going to define my interface, and I'm going to call this validatable as before, but I'm going to parameterize it with a type argument, and I'm going to have a function validate or check. Now, this check will return something. It needs to return either some errors if the validation failed, or the actual object if the validation was successful, so that I can do something on the happy path for that particular object. We have another video here on the channel on idiomatic and functional error handling in Kotlin, and I'm going to use the either type. I'm going to link that video in the description where we deal with the either type. I think it's functional error handling in Kotlin part 2 with either. So I'm going to have my check function or validate. Let's call this check. And I'm going to use either, and a specific version of either, I'm going to use either nil. Either nil means an either with a non-empty list of errors on the left-hand side, whatever the error type may be. So the either nil will have a data class, let's call this validation error with a val message as a string. And this will be my error type. Instead of using a throwable, I'm going to use my validation error here on the left-hand side. So either nil will have on the left-hand side validation error. On the right-hand side, it will have this t that I parameterize the validatable interface with. So this type, either nil, will either have a list of validation errors on the left-hand side, or the object subject to validation. Okay, so the validatable interface will take care of just the potential unhappy paths, and the errors themselves will be accumulated here on the either nil. Otherwise, on the happy path, I'm just going to return the same object, and then I can use it for whatever actual logic I may want. So I'm going to define my little data class. So data class, and I'm going to copy the data class here. Create portfolio. Boom. So the create portfolio. Now, this extends the validatable interface as I've described here. So validatable of the same type. So that would be create portfolio. Now, because this data class extends this interface, I need to override the check method. So let's do the override check. Okay. Now, how am I going to do this either nil? Well, this either nil will be, I'm going to implement this with a single expression. So I'm going to use either nil, and I'm going to use zip or accumulate, and I'm going to use a bunch of either types here on the unhappy paths, meaning that I'm going to describe potential errors here as the data structure either, or I'm going to return the same object, like this instance. So in this case, the unhappy paths will be something along these lines. I'm going to have if not storage users contains user ID. Then I'm going to return an either left. So this will be an either left. And I'm going to use the validation error. So I need to import either from the arrow library. By the way, we're using the arrow library in this project. I'm going to link the blog post in the description of this video where you can find either the POM XML or the Gradle file. In particular, for me, I have a POM XML, so I'm having a Maven project, and I have a bunch of dependencies here. I'm using Kotlin version 1.9 and the Arrow Core version 1.2. So these are the library versions that you should use for if you want to follow along with this blog post. Okay. Right, back to the either. So I'm going to use either left with validation error. So validation error. And I'm going to pass my message inside saying, what was the error? Error user ID does not exist. That is my unhappy path. So error user ID does not exist. And the either dot left is with a capital L. So either dot left. Or you can use validation error, and then you can use the extension function dot left in the arrow library if you want to do the same thing. I just wanted to make this super explicit. Okay. Else, either right with this instance. So this is one of the checks, one of the validation checks that I'm interested in. And this is one argument to either nil, zip, or accumulate. Another validation check would be if the amount is less than 0. So amount less than 0. Then I'm going to return either left with a big L, validation error, and this says amount is negative, else either write this with a capital R. And all other validations that you may want. So other validations that you want. So look at this. We have either nil, zip, or accumulate, and you have a bunch of eithers. And if one of these eithers has an error, then the errors will be accumulated from all the parameters of this function. Now, we need to supply a lambda here as the second argument of either nil, zip, or accumulate, which combines the correct, so-called correct values, but all of them are this instance. So I'm just going to use A, B. I'm going to return A. So I'm just going to supply this with an underscore. So in other words, this expression accumulates all the errors in a list of validation errors if one of these expressions is an error case, which is an either left, or if none of these are true, then that means that the override fun check will return an either nil with the right value, which is of type create portfolio, which is the exact this instance. Now, this structure is far more powerful than the previous two because of some reasons. For example, once you create a new data type, it comes along with its own validation logic. So each data type comes with its own validation logic. And that validation logic is specific to that data type, leaving the rest alone. So the create portfolio and change portfolio will have their own validation in the check function. And if you want to add a new event type, then that will come with its own validation logic and leaving the other two stuff alone. Whereas in the previous example, for example, we had the process function and you had to modify that. You had to add a new case in the process function. The second, and this is a new feature that neither of the previous two organizations had, which is the accumulation of errors. So you can have multiple errors returned from the unhappy path. Another reason why this organization is better than, for example, the first one where we had different logic for different event types. So the logic was different for every event type. But in this case, the compiler tells you to have validations for every event type. And also, you don't really have to overload the process functions. So in this case, with the validatable interface, when you create a new data type and you say that it extends the validatable interface, the compiler forces you to add your validation logic here next to the data type. Whereas in the previous case, you didn't really, or the compiler didn't force you to overload the process function with the new event type. The code would simply not compile if you tried to process that. And the second argument is that you still needed to change existing code in the form of this object fintech rather than keeping the code isolated in the new data type. So this structure with the data types extending an interface which forces you to do validation is far better compartmentalized because every data type comes with its own validation logic regardless of what the big company, the big fintech thing actually works. Okay. So this is an improvement over the previous two cases, fintech version 3. Now we can go one step further. We can actually separate the act of validation or the act of accumulating errors from the data type on which we're performing the validation. So instead of having the data types be validatable, we're going to create validator instances and then act on the type hierarchy of events that we're interested in. So I'm going to go create another object. I'm going to call this fintech version 4. And I'm going to have the same data class validation error, so that will be the same. And I'm going to have my data classes, so I'm going to have my create portfolio and change portfolio, and I'm going to keep them separate. So these are bags of data, going back to the philosophy of the first example and keeping them as pure events without any validation logic on their own. And so this would be the errors, then this would be the domain model. So this is events. And I'm going to design an interface that specifies or describes the act of validation. So I'm going to call this validator T. And I'm going to have a fun check. And this will take an argument of type, let's call this event or item, which is a T. And this will be an either nil with validation errors on the left-hand side or T on the right-hand side. So I'm separating the act of validation from the events that I'm running the validation logic on. So, for example, I'm going to create an item of type validator T specific to create portfolio. So I'm going to create a val. Let's call this create portfolio validator. So notice that I'm creating an object that is going to just perform the validation on the first item type. So create portfolio validator. And this is an object that extends validator of type create portfolio. So this is going to be an anonymous class. And I'm going to override the check item. Okay. And then I'm going to perform my validation logic. So this is going to be the either nil, zip, or accumulate. So the same logic, either nil, zip, or accumulate. Now, in this case, I'm going to have my item.userid. And then I'm going to have validation error user item.userid. Else either write item, if amount, this is going to be item.amount, either left with validation error amount is negative, either right with item, and the same combination logic. So I'm just referring to the item instead of the this object because the item is now an argument. So we're essentially keeping the features from fintech version 3, which is the ability to accumulate errors and the ability to keep the validation logic separate for every event type. And I'm also separating the act of validation from the data type itself. So I'm keeping the data class pure, and I'm creating a separate object whose only purpose is to subject create portfolio events to the validation logic. Now, once we've created this separation, so we have events and we have the validation API, and then we have validation implementations for every event type. Then, in the, let's say, fintech logic, we have a single function that takes an argument t. I'm going to call this process. So we have a single function for pretty much everyone. Then we have an item or event of type t. And then we have a validator, which is a validator t. So in the presence of a validator t, we can subject this event to the validation logic and then perform the happy path. And here I'm going to use the either scope. So either, I'm going to use the DSL from arrow core. So I'm going to use the either from arrow core. And then I'm going to have my val, let's call this validated. And I'm going to assume that this validated t is the item event after it has been subject to the validation logic. So I'm going to say validator.check on the event. Now, because I'm in the either scope, I'm going to use bind here. And we talked about bind and the either scope in the functional error handling video that I talked about a little bit earlier. And then this is the happy path. So I don't really care how this validation logic actually works, but here I only care about my own business logic. So this is my happy path. Notice that in my fintech application, I'm going to create some artificial space here. Look at how easy it is in the fintech application to perform validation checks. It says validator.check event bind, whatever the validator check does, and that's the subject of the validation API or library. And after that, I can deal with my absolutely fabulous fintech application. So I can say print line, I don't know, successfully processed the event, and I can inject the event inside. And on the unhappy path, if you want to deal with errors, you can say on left, and given the errors, you can print them out, or you can process them in any way. You can store them, you can recover from them, and so on and so forth. We discussed the functional error handling videos. So you say found validation errors, and I'm going to inject errors map. We have it message, for example. All right, cool. So we have found validation errors map it message, and that's going to be my main fintech logic. And I can actually do something like this, and I can type in a main, and I can say process, and I can use a create portfolio with a user ID, let's say Daniel, which doesn't exist in the database, and -10.0, which is the amount. And the second argument is going to be my create portfolio validator. This is going to be my validation logic. If I run this application, I'm going to have all my validation errors. Look at that. We have found validation errors, non-empty list, says error, user Daniel does not exist, amount is negative. So all of my errors can now be processed by this function, and we've separated the active validation from the event type itself, and keeping the logic of the fintech clean. And finally, we can go the extra mile and make this syntax or the API a little bit nicer. For example, getting back to the validation API in the interface validator t, instead of doing the fun check with item.t, why don't we create an extension function, t.check? If we do t.check, obviously we're going to have the API change a little bit. So I'm going to have override fun create portfolio.check. And in this case, the item is going to be this. So I'm going to go back to the this implementation that we had earlier. So we have this first, and we have item amount, and then we have either right this. So we've made the API a little bit nicer, t.check, and in this case, we're going to have to use event.check. But the validator itself needs to be passed as a context object. So I'm going to have a context. I'm going to use a context receiver in this case. Validator t. So validator t. So in the context of validator t, this event will have the extension method check because the validator t grants the presence of this extension method. So event check bind. And in this case, I'm going to use with create portfolio validator. And I'm going to use process with create portfolio Daniel 10. And I've just granted myself another feature. Let's call this number 4, which is the ability to pass any sort of validation logic that I want. So change the validation logic at will. So I can create multiple portfolio validators. So I can create different objects that extend validator or create portfolio, and I can pass the one that I want as a context object. And this application will run just the same as it did earlier. Found validation errors, user Daniel does not exist, amount is negative. And the API is clean. The only thing that we probably need to change is that the validator itself should be a validator scope, really. So I'm going to rename this to validator scope instead. So we read this logic as in the context of validation, which is validator scope, we have access to the check extension method. We can run our validation logic, which can deal with the unhappy paths as it sees fit. And after that, we just consider the happy path. So successfully process the event, and I have validated here instead of the original event. And if you want to treat errors, you can have various catch functions like on left, and you can treat the errors as you see fit. Now, notice that throughout the code that I've written in this video, I've never once mentioned the idea of a type class. This validator scope thing is called a type class, meaning that the act of validation or the ability for this type to perform validation checks can be added for some types and not for others. For example, in this case, we have validation checks for create portfolios, but we don't have validation checks for strings or for integers or for whatever other types that you don't want to support the act of validation. The type class is the ability to perform something for some types and not for others. This is a type class. So there you have it, folks. Type classes in Kotlin as a practical design pattern on how to organize your code better. I hope you liked this video and found it valuable. If you did, go ahead and click the like button and subscribe to the channel for more videos like this. And check out the blog post and the website for hundreds of hours on everything that you can imagine from Scala and Kotlin and so much more. I'm waiting for you in the next video. And until next time, this is Daniel signing off.